Hi. In this lecture, we will see what is known as Cramer's rule, which is a method to solve a system of linear equations. So we just took three linear equations in three unknowns. We see how to use this Cramer's rule to solve for x, y and z. Using that is Cramer's rule means a method to solve systems of linear equations employing determinants, making use of determinants. Okay. Now these are the equations. Let's say this is equation 1, equation 2, equation 3. a1x plus b1y plus c1z is d1. These are all some numbers. a2x plus b2y plus c2z is d2. a3x plus b3y plus c3z is equal to d3. So, okay, we will see how to use this Cramer's rule. You will have to extract 4 determinants from this system. First, this determinant, say delta. It's a determinant formed out of the coefficients of x, y, z. You don't have to consider the d's here. That is a1, b1, c1. First row, it's like this. a1, b1, c1. a2, b2, c2. a3, b3, c3. Call this as a determinant delta. Again, next determinant is delta x. Here what you should do, it is same as delta, but the first column made out of a1, a2, a3. That first column elements you should replace by d1, d2, d3. So first column d1, d2, d3. These two will remain as it is. b1, c1, b2, c2, b3, c3. You have to evaluate the determinant. You call it as delta x. Similarly, delta y will be the second column here, that you should replace by d1, d2, d3. That is delta y is equal to, otherwise the determinant is same. a1, a2, a3. The second one, that you should replace by the d values, d1, d2, d3. Third column will remain as it is, c1, c2 and c3. Then similarly delta z, keep the two columns as they are. The third column you replace by d1, d2, d3. So a1, a2, a3, b1, b2, b3, d1, d2, d3. You have to evaluate all these 4 determinants. How do you get the determinants? First determinant is simply the coefficients of x and y, z, x, y and z forming the elements of the determinant. Delta sub x will be same as determinant delta, in which the first column is replaced by the constants which are there on the right side. The systems of linear equation is called as non-homogeneous system because you have d1, d2, d3. If you have 0, 0, 0, you call it as homogeneous system of linear equation. This is a non-homogeneous system of linear equation. We assume delta is not 0. Then x is equal to delta sub x by delta. You know the value of delta x. You have to evaluate the determinant. You know the value of delta x. You know the value of delta. Simply divide, you get x. Similarly, y will be delta sub y by delta. Z will be delta sub z by delta. So you can easily solve for x, y, z. Suppose if the determinant happens to be having big numbers, you can use properties of the determinant so that you can evaluate it with less effort. Okay, we'll take an example. You take this system of equations, 3 equations in 3 unknown linear equations. You have to solve for x, y and z using Cramer's rule. So these are all d1, d2, d3. A1, B1, C1 like that. First find out delta. Delta is made of the coefficients of x, y, z. 3 minus 4 minus 2 minus 5 minus 2 3 1 1 minus 1 coefficients of x, y, z. You should evaluate. 3 into, forget about this column, this row, 2 minus 3. 3 into 2 minus 3. Minus of minus 4, so plus 4 into, forget about this column and this row, 5 minus 3. Then minus 2, this minus is there in this number. Forget about this row and this column, minus 5 plus 2. So this is minus 3 plus 8 plus 6. Is it correct? Minus 5 plus 2, minus 3 into minus 2 plus 6. Then 5 minus 3 is 2, 2 into 4 is 8. 2 minus 3 is minus 1 into 3 minus 3. So this is 11. Delta is 11. Then delta x, delta subscript x. First column should be replaced by these constants. So 7, 4, minus 4. Other things will be as they are. Minus 4, minus 2, 1, minus 2, 3, minus 1. Evaluate this now. When you evaluate this, 7 into 2, forget about this column, this row, 2 minus 3, plus 4 into, forget about this row, this column, minus 4 plus 12, then minus 2, forget about this row, this column, 4 minus 8. This simplify, 7, this is minus 1, so minus 7 plus 8, so plus 32, minus 4, so plus 8 again. So 40 and minus 7 here, so 33, delta x. Then we will find delta y. So here I think so I'll just do here delta y. This will be same as 3 minus 5, 1, only this will change, 7, 4 minus 4. Evaluate this. 3 into, forget about this column, this row, minus 4 plus 12, minus 7 into, this column, this row will go, 5 minus 3, minus 2 into 20 minus 4. So minus 4 plus 12 plus 8, 24 here, 2 minus 7, so minus 14, 16 minus 2, minus 32. Okay, plus 10, so minus 22 here. Okay, so we already got the value of delta, delta sub x, delta sub y. Now we will see how to get delta sub z. The coefficients of z should now be replaced by the constants here on the right side of the equations. So 3 minus 5, 1, minus 4 minus 2, 1, So here you should put 7, 4, minus 4. This is delta Z. You evaluate it. 3 into 8 minus 4 plus 4 into 20 minus 4 plus 7 into minus 5 plus 2. Simplify. 4 into 3, 12. 16 into 4, 64. Minus 21. This is 76 minus 21, which is 55. So we know that x is del sub x by delta, which is 33 by 11, so 3. So value of x is 3. Then value of y is delta sub y by delta. Delta sub y is minus 22 by 11, so minus 2. Y is minus 2. Z will be delta sub z by delta. Delta sub z is 55. Delta is 11. You get 5. So the value of z is 5. So you obtain the value of x, y, z. You can cross check by substituting the values in these equations. The equations will satisfy. Okay? Thank you.